1.2, displaying quantitative data with graphs. Numerical data now. Our goal, make and interpret dot plots, stem plots, identify shape, describe, compare. You'll see. SOCAF. That means nothing to you now, but it will maybe someday. There we go. See, a dot plot. Very easy one. A dot plot, you put a dot for each piece of data. How do you make one? You draw an axis. You select the values of it and label. Make sure you label. Don't lose points. Then you make a dot for every time an occurrence happens. So if I look at this, it tells me 3 times they scored 5 goals. Pretty easy. I wouldn't take notes on this. Just make sure you label. Label. This is important though. How do you describe it? A dot plot is roughly symmetric if it has equal number of dots on each side. Alright? Or about approximately symmetric is what you say, or roughly symmetric. Okay? So that graph up there would be roughly symmetric. Now if you're skewed to the right, what that means is you have data over here that's pulling your mean to the right. Okay? It's being pulled that direction because you have some outliers. For example, if I had a basketball team and everyone was 6 foot tall, there's one guy 7'2". That 7'2" guy is skewing my average data to the right to make it too large. Skew left is the opposite. That'd be like if I had a 3-inch person on my team. I don't know, that's not possible. A tardigrade. Minuscule. Okay? So skewed is the direction it's pulling the mean in a way. Not in a way, that is what it is. It is what it is, what it is, what it isn't. Skewness is the direction it's pulling the mean. Okay? It's pulling it in one direction. Not pulling it to a one direction constant. I can't make fun. They're not that bad. Don't hate me. Alright, now how do we describe it? When you describe a graph, remember SOCAV. S-O-C-V. You're looking for the shape, the outliers, the center, and the variability. Okay? Now make sure when you don't just say the shape is symmetric, the outliers just 2, the center is 5, the variability is a lot. That means nothing. You need to say, you need context. What I mean by context is, if we're looking at goals scored, here's our graph. The shape, the distribution of goals scored is skewed to the right, because that 9 and 10 over there, they're pulling the mean over. There is a peak at 1 goal. That's our center. Okay. So currently we have our shape, we have our peak, gap between 5 and 9 goals. Sometimes I can go somewhere else. Outliers. We have outliers when they scored 9 or 10 goals. The center, we would say the median is 2 goals scored, because that would be our center of this data. And our variability goals, we would say the goals vary from 1 to 10 goals scored. Now, please, when you're answering a question that says describe the distribution, don't write it as a paragraph. Combine these as sentences. Don't be like shape, this, outliers, this, put. It's going to read the same, but you won't have the SOCAV actually written in. SOCAV, so, kuv, sakv, sak. Don't too far back. Is that a redo? Alright. Here we go. Is there context? Yes. We're talking about the goals, the team. That's the context we're talking about. Now, how do we compare distributions? Make sure when you're comparing distributions, you're going to use words like greater than, less than, the same as, equal to. Okay? You could say the distribution of household size in South Africa is skewed right, whereas the UK is not. That was not the example. You could say that there's greater variability in South Africa than UK for household size. 26. Wow. It's a big house. It's a small house with a lot of people. So let's try this. Shape. We're comparing these two sets of data. We're looking at UK household size and South Africa household size, right? So when I look at this, I would say the UK sample size is roughly symmetric with a single peak at 4. The distribution in South Africa is skewed to the right with a single peak at 4. And most people are in the gap of 15 and 16. Or in a clear gap between 15 and 26. So possible outlier. Outliers. There don't appear to be any outliers in the UK distribution, where the South African has 2 outliers, possibly with 15 and 26 people. Center. Household size in South African students tend to be larger than for UK students. Okay. And variability, again, we'd say that South Africa varies more than the UK. All right, we're going to do a lot of this in class too, guys. Context, comparative language. How to make a stem plot. Y'all have seen stem plots. It's a plant and stems. There's plots. I don't know. Don't write this down, guys. This is what a stem plot is. How to do a stem plot. First, you make your stems. So if we're looking at this data, our stems are in the tens place because they all share a tens place. That's as large as it gets. Okay. Then we add our leaves, and then we make sure they're in order. Then we add a key. So we have to put 4/9 means 49 pairs of shoes. That's important. Context is important. All right. You've probably done a stem and leaf plot before. I'm not going to spend a lot of time on this. Now, sometimes we want to show that most of the data is either in the lower half or upper half of, let's say, the 20s. Most of the days like 21, 22. There's not many 29s. Then we might split the stem. Is that used a lot? No. But this is what they look like. We split them. Okay? To compare, you can see 0. So any data between 0 and 4 goes on that one. Any data between 5 and 9 goes to the next stem. Okay? And we also have females on one side, males on the other, so we can compare the distributions. Like a dot plot at this point. Am I a huge fan of stem plots? No, dot plots are always my favorite to go to. Now a histogram. So we use bar graphs for qualitative data and we use histograms for quantitative data. Same concept, different names. Now we know what a dot plot looks like. You guys have seen histograms before. Boom, it's a bar graph. Don't call it a bar graph, it's a histogram because we're dealing with quantitative data. Okay? That's the only difference. You use a histogram is always frequency on the left-hand side, just like a bar graph is. Frequency or count. Okay? How do you make a histogram? Now this is important when you make a histogram because you're dealing with numbers. A lot of times there's a whole bunch of 2.7s, 2.8. You don't want to make a bar graph for that data in the lower right-hand corner. For every different piece of information, it's different. So instead what you do is you make a frequency. So for this one, we don't want to make for all of them, so we're going to make a range. Oopsie doodle. So for this one, I'm going to choose widths of 5. So from 0 to less than 5, 5 to less than 10, 10 to less than 15. You could make 10 by 2s. There's a lot of ways to do it. And then we're going to count up how many were between 0 and 5, how many were between 5 and 10, and so on and so forth. And then we make our, not bar graph, but histogram. Boom. In this way, we aren't plotting all 100 or 50 pieces of data. We're only graphing 6. It's easier to digest and look at. One of the problems with histograms is you don't know specific data. Like, you don't know if everything was close to 0 or if it's closer to 5. Okay? You don't know specifics. Oh. Again, they're different histograms. Bar graphs are different. You can also use proportions or percents instead of counts. And just because a graph looks nice doesn't mean it has good information. Hope you guys learned something today. Enjoy.